So now coming to part 4, which is building training and testing the CNN on Cipher 10 datasets. So in deep learning, a convolutional neural network is a class of artificial neural network most commonly applied to analyze visual imagery. CNNs use a mathematical operation called convolution in place of general matrix multiplication in at least one of their layers. So the design of the model, including the diagram of the neural network architecture and the list of the critical information of each layer is given below. We can see that the design of the model consists of 4 convolutional layers with max pooling operation after every 2 convolutional layers. So the first layer has 32 image filters and the second one has 64 filters followed by max pooling operations. Then the third and the fourth layers have 128 image filters, followed by max pooling. Then we flatten the outputs of these layers and pass them to fully connected dense layers with a ReLU activation function. Then pass them to the softmax dense layer, which maps to the number of classification categories. So for updating the gradients, we use a categorical cross entropy loss function with a learning rate of LE2 and use the Atom optimizer to update the weights. So after building training and testing the model, copy the results of the test into a selection of the project report. For this, we can see the results of the test in training the model for 5,000 steps, testing the accuracy of the model for every 100 steps. So here we are doing it for 13 epochs in order to achieve 5,000 steps in model training, and we are testing it on every 100 steps. So here there are 13 epochs, and we can see that for every 100 for every 100 we can see the accuracy and the loss. So as we can see here, the accuracy is 0.2578 and the loss is 1.9413, and the same continues for every 100 epochs. Like for 200 we can see the accuracy and loss, for 300 we can see accuracy and loss, and so for every epoch we can see the accuracy and loss. So there are 13 epochs. So here we can see for epoch 5 the accuracy and the time, and it continues until the 13 epochs. So this is the 11. For the 12, this is the accuracy, and we can also see the epoch receives better accuracy, like 53.47, which is greater than 53.33. And this is the final epoch. So here we can also see the best accuracy pre-session, which is 53.47, and this is time. So coming to the report on the results of testing the model, we can see that the final accuracy of the model after training for 5,000 steps is quite low at 53.47%. So this is due to the complexity of the classification of images in the Cipher 10 dataset. The simple CNN we use to learn from the dataset doesn't have enough layers to process the features of images in the dataset, and it needs additional layers and training time. We can see the model accuracy tip up fast as training begins before dropping rapidly. So this is the architecture of the neural network. So here we can see there are 32 input layers, and we have hidden layers and 10 output layers. So the input layer of a neural network is composed of artificial input neurons and brings the initial data into the system for further processing by subsequent layers of artificial neurons. And this hidden layer is in an artificial neural network. It is a layer in between the input and the output layers, where artificial neurons take in a set of weighted out inputs and produce an output through an activation function. So this is the output layer, which is the final layer in the neural network where desired predictions are obtained. So there is one output layer in a neural network that produces the desired final prediction. So this is all about the architecture of the neural network. And coming to the part 5, which is comparing the convolutional neural network performance. So here we are comparing the accuracy data points of ACC underscore CNN underscore MNIST, which is in the assignment 4. So comparing it with the Cipher 10 data accuracy. I've also pasted the accuracy results of assignment 4 as you can see below. So this is all the results of the assignment 4. And after comparing these, so this is all about the comparison of the new CNN's performance. So here we can see the sample loss and accuracy for 18 epochs in total. So this is for the 15th epoch, and the same goes on until the 18th epoch. So after comparing these are the results that I observed. So here we are asked to compare the performance of the two CNNs that have been used on the data sets MNIST and Cipher10. So as we can observe from the above test data sets accuracy scores. So these are the scores, and so based on the scores, the CNN model trained on the MNIST dataset, it achieves an accuracy of 99%. 99% accuracy, while the CNN model trained on the Cipher 10, Cipher 10 dataset, it only achieves an accuracy of 53.47%. So we can see it in the results here. And we are also asked to write the, like using critical thinking, we are asked to write a report on the results of comparing their performance, which is the accuracy levels, in which student is expected to provide possible reasons to explain the gap in the performance of the two CNNs used on these two data sets, if such a gap exists. So for this, this disparity in the accuracy of the models, it can be attributed to the Cipher 10 datasets complexity. The number of MNIST datasets are much easier to train the CNN model uh, than uh, than much more complex and higher dimensional Cipher 10 dataset. So usually larger and complex datasets need to be trained for much longer epochs so that the model can accurately learn from the data. So this is all about the comparison, which is asked in the part 5. And so in this, with so in this, I have told about the building, training, and testing CNN on Cipher 10 dataset and comparing it with the neural network. And we can see the results here for the for building and training. These are the results. And this is the architecture of the neural network. And finally, this is the comparison of convolutional neural networks performance, which is based on the assignment 4.